Whether you're talking about robot dogs, robot fish, or robot octopus arms, mimicking and adapting nature's designs often leads to the best design. Industrial automation company Festo has learned this lesson well. It has designed robotic butterflies, kangaroos, ants, and now, a robotic flying bat. Flying bots like quadcopters and gliders have come on in leaps and bounds in recent years, but engineers are still chasing the holy grail of aerial robotics, replicating the complex flight of a bat. A team of scientists from Caltech and the University of Illinois at Urbana-Champaign have created what they claim is the nearest bat biomimic yet. Its name? Batbot. This robotic bat weighs just 93 grams and has a roughly 1-foot wingspan. Its flight mechanism replicates the complex movements of bat wings, allowing it to bank and dive like the real thing. But it only uses 9 joints instead of a bat's 40. Each joint is 3D printed and 5 are individually controlled motors. The bot's bones are made from carbon fiber while its wing membrane is a custom silicone-based material an incredible 56 microns thick. An onboard computer is used to steer the bot, but flight time is limited due to battery constraints and current prototypes are too fragile for real-world use. At the moment, the Batbot is simply an engineering work of art, but it could also have useful applications. A more developer version could be used for the same sort of surveying tasks currently being undertaken by small drones, like looking over a building site or even a disaster area, but the Batwing mechanism would offer greater power efficiency and more flexibility for maneuvering. Plus, the Batbot's design is safer than that of today's quadcopters. Getting hit by a stretchy membrane will do much less damage than a spinning rotor. The robot is officially called the Bionic Flying Fox. It features a lightweight frame, a custom membrane for the wings, and uses machine learning to fly semi-autonomously. The robot relies on a system of gears and motors to provide the flying power and steering. The wings themselves are made of 2 airtight films and a knitted elastane fabric, which is stitched together at more than 40,000 points, making these wings both lightweight and durable. It's unlikely this particular robot will ever see any commercial applications, but it's a nice demonstration of the state of robotics at the moment. With just a few simple materials, it's possible to build a complex flying machine that successfully mimics a style of flight that took animals millions of years to evolve.